Hi, my name is Carole Holmberg. I'm the planetarium manager at the Museum of York County. This next week, starting tomorrow, is National Chemistry Week. We usually have an event and some activities, and of course, being closed, we can't have them this week, but luckily we can have them virtually. The theme this year is Sticking with Chemistry, all about adhesives and glues and how chemistry is involved. I hope that you enjoy the video that follows and the various activities and demos. Have you ever seen a gecko? Other than the Geico gecko, of course. Have you ever seen a real gecko? Sometimes people have them as pets. There actually is a gecko that has been introduced here in South Carolina. This is the Mediterranean gecko. They're not from here, as the name suggests. They're actually from northern Africa and southern Europe, but they have found their way into Florida and the southeast, including South Carolina. They're found mainly in urban areas. They've been spotted in Columbia, in Charleston, in Hanahan, and Pooler, and according to the University of Georgia's Southern Savannah River Ecological Laboratory, they are making their way through the mid-Atlantic states and even as far as north as Illinois. If you haven't seen one, they haven't been spotted in York County or anywhere in the Charlotte area yet, but according to the Savannah River Ecological Laboratory, they will eventually make their way here. What geckos are known for, one of the things, is their stickiness. Geckos can run very swiftly. They can climb, scale vertical walls. They can hang upside down from the ceiling. How do they do that? Do they have suction cups? Do they have little barbs on their feet? Do they have claws? Do they make some sort of sticky slime? In reality, it's none of those things. I want to show you a close-up of a gecko foot. This is what the underside of a foot looks like. They have pads. They are actually quite smooth. They're not sticky. They don't suck or stick at all. They use chemistry, something called the van der Waals forces. Van der Waals forces are not very powerful, and to get them to work, you need to get very, very close. I've got a gecko toe magnified. This one is 1,660 times magnified. You can see that gecko toes are composed of lots of little hairs called setae. Each hair is thinner than a human hair. They are very thin and they need to get in contact with the molecules of a wall in order to stick. This one is 8,700 times magnified. The setae have on their ends, as you can see here, what looks like split ends. They look fuzzy here. These thin ends are called spatulae because they are shaped like little spatulas. All of them have lots of surface area and they get very close to a wall or ceiling. A gecko can hang by a single toe by holding its feet just so. Geckos cannot stick to everything. For instance, Teflon has fluorine molecules which do not react to van der Waals forces, so geckos can't stick to Teflon. And wet surfaces such as water all disrupt their sticking ability. Gecko feet and their stickiness are studied by scientists. They hope to someday have robots that can scale vertical walls and wash windows. They hope to make sticky pads so military people can climb mountains and scale walls as well. They also hope to use what the gecko uses, van der Waals forces, to repair wounds so they stick together without stitches. Well, I hope you found that very useful. I hope you don't see a gecko in the wild, at least not here. But if you see a pet gecko anywhere, if you see them climbing a wall or even the ceiling, you can know that they do it through chemistry. I hope that you now understand how scientists hope to harness the power of the gecko. Although Velcro was popularized by the space program, Velcro was not invented by the space program. And to learn a little bit more about Velcro, we're going to look back to its invention, and then I'm going to show you how it is used more. It all started in 1941 when a Swiss engineer was walking with his dog in the Alps. He noticed that burdock burrs kept sticking to his coat and the fur of his dog, and he wondered why that was. He examined them under a microscope and noted there are hundreds of hooks that caught on everything with a loop, such as clothing or fur, and you can see a close-up of a burr spine right there. He saw the possibility of binding two materials reversibly in a simple fashion if he could figure out how to duplicate the hooks and loops. He patented in 1955 and subsequently refined and developed his practical manufacture until commercial introduction was in the late 1950s. The fastener consisted of two components, a fabric strip with tiny hooks that he could mate with another fabric strip with small loops, attaching temporarily until pulled apart. Initially made of cotton, which proved impractical, the fastener was eventually constructed with polyester and nylon. He called his invention Velcro, a combination of the French word for velour, which means velvet, and crochet, which means hook. Velcro consists of two parts, a strip, circle, or square, with hooks that mate with another fabric strip, circle, or square with small loops. The two components are sewn or otherwise attached to the opposing surface to be fastened. When the two are pressed together, the hooks catch in the loops and the two pieces fasten temporarily. When separated by pulling the two surfaces apart, the strips make a distinctive ripping sound. That's the fun part. Astronauts on the International Space Station use Velcro in many different ways, so things that don't float away into microgravity. The bags that they sleep in are Velcroed to a wall, and when they eat, their food packaging also has Velcro.
Hello everyone, I'm going to show you how to make a peanut butter and jelly sandwich from the International Space Station. Every time we eat, it's kind of fun. Everything will float around if you don't manage it. So we have some tape to stick things on our table here, as well as a bunch of Velcro. All right, so the first thing we need for our sandwich is a piece of bread. Well, up here we don't have bread like you do on Earth, but we have tortillas. So we use tortillas a lot for sandwiches. So that's what I'm going to use for my peanut butter and jelly. I'm going to stick that down to some tape here so it doesn't go floating away while I'm getting everything else ready. So I'll get my peanut butter out, and even the lids on the peanut butter have a piece of Velcro on it so they don't go floating away. If I let it go, it'll kind of just float there for a little while, and then eventually the air conditioning system in here will take it away somewhere else. So I don't want to lose it, so I'm going to stick it on the table. I'll scoop out some peanut butter for my sandwich. I got to stick this somewhere, otherwise it just goes floating away too. But just for now, if it's just a few seconds like this, I can just leave it and let it float. I'll spread the peanut butter on my sandwich, into the tortilla, and then I'll get my jelly ready. Post-its. A lot of things you got to think about and manage while you're eating up here. And you just spread the jelly on the sandwich. That as well needs to get attached to the table. So there's my peanut butter and jelly tortilla or sandwich. From up here, I'll just kind of close it up and enjoy. See if you guys can enjoy it as it's coming to you.
I have two actual examples of astronaut food that was once destined for the space shuttle: apple jelly and Lorna Doone cookies. Astronauts get to choose from a menu of over 100 different foods now, and the nutrition and calories of daily meals are carefully calculated. When the food is prepared on Earth, before being sent to the International Space Station, all the original packaging is usually removed and discarded, and the food is repackaged because the inks or packaging materials could contain something harmful in the enclosed environment of a space mission. We call this off-gassing. Rather than test every ink or plastic used for packaging, it's easier just to replace it all. Finally, each food item has a dot of hook Velcro stuck on so that it attaches to a food tray and doesn't float around, as you just saw. Scientists have been inspired by how Velcro interlocks to imagine several products, including using fuzzy silicon carbide fibers for lightweight, temperature-resistant parts for jet engines. Such engine parts have to resist extreme temperature changes while being as tough and light as possible. And silicon carbide has a very high temperature stable ultra density material, and that can be woven into a carpet-like material. Each fiber contains thousands of tiny hooks on its surface that interlock and anchor it, which makes the material more resistant to extreme temperature changes and able to withstand greater deformation. The story behind Velcro reminds us all to observe carefully the natural world around us and to keep wondering why. Velcro is used extensively both here on Earth and in space by the astronauts. How many times can you stick a Post-it note? If you would like to try this yourself at home, you will need a few Post-it notes. You might want a sheet of paper and a glue stick to make your own Post-it notes. To record your results, a sheet of paper and pen are handy. We do have a log sheet that you can print out in the comments. Post-its are small pieces of paper with a strip of adhesive along the top edge of the back side. Unlike other kinds of tape, the adhesive on Post-it notes allows the paper to be stuck to surfaces, but also to be peeled easily away and restuck to another surface. A 3M scientist discovered the adhesive on Post-it notes by accident, but didn't have a use for it at first because it wasn't very sticky. Later, Art Fry, another 3M engineer, was making pages in a choir songbook using small pieces of paper. The trouble was the paper would never stick in place and would fall out of his book. Then Fry, who knew about the new glue, had a great idea. He could use the new adhesive for removable bookmarks. In 1980, the removable bookmarks with the not-so-sticky adhesive were first sold as the classic yellow Post-it note that everyone knows today. Post-it notes have been a success and 40 years later, they are found in schools, homes, and offices around the world. Now for the experiment part. I want you to take a fresh new Post-it note and start sticking it. Stick it once, pull it up, and stick it again at the same spot. That's 2, and keep on sticking until it doesn't stick anymore. 3, 4, 5, 6, and I'll get back to you in a few minutes. 101, 102, 103. Oh my goodness, it's not sticking anymore. If you have a log sheet or just a sheet of paper, you can write on it the number of sheets. And then what did you observe? 102. What did you observe? Other than it's not sticky, do you see anything on the surface? I don't. So just non-sticky and write it down. And then try it on different surfaces. I've put down sandy, wet, rough. You can also try it on your skin. 1, 2, see how long it sticks. 3. You can also make your own Post-its. Strip of paper. My Post-its are 3 by 3, so I made it very similar. And take a glue stick, stick the glue stick along one edge of the paper. And you can see how that compares. 1, 2. What do you notice? What does it do to the paper? Try it on the wet paper. Try it on all the surfaces, and then write down your results. What did you observe? Which surface is best? Have you figured it out? Did the homemade note compare to the actual Post-it note? Some people, as I mentioned, they stick Post-its to their clothing to remind them of stuff. Is that a good idea? Is sticking it to your hand a good idea? Now you'll be able to say. Now, where's the chemistry? How do these Post-it notes work? They're not very sticky. That's because it's not a firm strip of glue. The Post-it stickiness is actually a bunch of little spheres that are close together. So they don't stick as well as a strip of glue, and they can deform a lot without tearing the paper. Hi, we're going to make homemade glue. It's got vinegar and water and milk. And the milk, we recommend skim milk or fat-free milk. They're kind of the same thing. And that's because the fat in milk interferes with the making of the glue. So while any milk will do, skim milk is best. You're going to need either paper coffee filters or paper towels, cups or glasses to heat the milk in and make the glue. They're going to have to be disposable glasses as you're making glue, and things to stir the ingredients in. I'm going to wear my goggles, and when you make this glue, because it is glue, you should probably wear old clothes or have yourself covered in some way. And because the milk needs to be heated, about a half a cup of milk should be fine. And microwave the milk. About 30 seconds is fine, or you can heat the milk on a stove to about 78 degrees. Don't overheat the milk. The milk has been heated, and I pour it into a clear cup so we can see a little bit better. Add 1 tablespoon of vinegar. About, doesn't have to be exact. We're going to stir the vinegar milk mixture. And what you should notice is that the milk will get kind of clumpy. And keep on stirring until the clumps stop forming. The clumps stop forming. We're going to wait 5 minutes to allow it to continue to separate and the solids, which are heavier, to fall to the bottom. And well, the milk has separated. Hopefully you can see at the very bottom we have the solids, and at the top we have the liquid. What we've made is curds and whey, kind of like Miss Muffet. The solids are called the curds, and the liquid is called the whey. And we added the vinegar to separate them, and now we just need the curds. So we're gonna kind of filter out the whey. I've got a coffee filter to do that, and you can use a paper towel, you can use a cheesecloth, anything to strain. Pour first the liquid, the whey. And what you can do eventually is throw it out. I've got a 1/3 cup that I am going to simply put the whey in. It's in a neat fashion. And then eventually you're going to get to the solids, the curds, which we want to save. And here we have the curds. Stir it, and we're going to add a little bit of baking soda, 1/4 teaspoon or so. And we're going to continue to stir until it stops bubbling. Now this glue is going to last for only about a day. I took some popsicle sticks and I glued the glue to hold 2 popsicle sticks together last night. I made glue. And I also glued 2 popsicle sticks with school glue. And I thought I would compare the two. And what you can just glue them, let them dry about 24 hours, and then try and snap them apart and see how best they do. First, the homemade glue. Oh, that is strong. See, the stick broke before the glue. And here's the school glue. And the school glue is just as strong. The stick is going to snap before the glue. Homemade glue is pretty strong. Remember, you only got about 1 day worth. You can throw everything that you made out. Extra glue, the whey, you can just pour down the drain. And remember, of course, not to eat homemade glue. The milk has a protein called casein, and casein is a long, tangled strip. Vinegar was only used to separate the curds from the whey. And the baking soda was just used to neutralize the vinegar. So it's really just this milk protein, all tangled in strips, that makes the glue. In this activity, we'll be making some slime. Slime is so much fun. It's a stress reliever, and you can spend hours with it. It's pretty easy to make, and there are different recipes. For it, you're going to need borax, some water, and some glue. You are going to need a cup and stir sticks. The first thing to do is to take the borax and just take a little bit, maybe about 1/4 teaspoon. You don't need much borax at all. And we're going to add some water. So there's the water, and we're going to dissolve it in the water. And they call this a super saturated solution. We're going to take and we're going to pour out glue and water. You can use as much or as little as you want. It should be about 50-50. 50% glue and adding that borax solution. It only takes a few drops, and you don't want to add too much borax. So watch it as you do it. An eyedropper sometimes helps. I don't have one, so just do it a few drops at a time. We're going to stir with our stir rod. The slime is going to form on the rod more and more until most of the glue water is turned into slime. You want to leave a little bit because you don't want it to be too stiff. And we'll keep stirring until most of the glue water is made into the slime. There's just a little bit left. You can pull it out. Remember, you've got it. It's best to have a little bit of the glue water left because you don't want it to be too tough, too stiff. And once it's done, you knead it with your hands, because the more that you knead it, the better it gets. There you have it, slime. Now, you can add food coloring, or you can add glitter. If you want to make fluorescent slime, is to take the tip of a highlighter and put it in the water and soak it, and then your slime will glow beautifully in black light. Slime is, it sometimes acts like a liquid, and sometimes it acts like a solid. I hope you enjoy our activities for Sticking with Chemistry Week, and that you'll do some of them and let us know. Put in the comments if you have a pet gecko, or if you have made the glue or the slime, because that's fun.